Okay, this is for college algebra, topic 2.5. We'll be solving linear inequalities that use absolute value signs. Now let's start off with number 7. Number 7, we have a quantity in the absolute value sign, and we also are using a less than or equal to a constant. Whenever we're using less than or equal to, or should I say less than, I'll point out the less than, this is the procedure. We remove the absolute value sign, so we'll have 2/3 x minus 5 less than or equal to 3. Again, this is only with the less than sign. We're going to repeat the less than sign here and then write in -3, the opposite of whatever this value is. Once we have this, we begin to solve from the inside. So I'm going to add 5 here. That'll cancel out the 5. Then I add 5 to all sides. That gives me 2 less than or equal to 2/3 x and less than or equal to 8. Now from here, I want to get rid of the denominator here, so I'm going to multiply everything by the LCD. In this case, it will be 3. So 3 times each one of these terms, we'll get 6 less than or equal to 2x less than or equal to 24. Now, continue to solve for x. I'm going to divide everything by 2, and we'll get x here. But we'll divide 2 on all sides, so we'll end up with 3 less than or equal to x less than or equal to 12. Now, this is the set notation for this. The graphic for this would be a solid line with solids at both ends and 3 and 12 here. And the interval notation for this will be a bracket, 3, 12, and bracket. Now, let's deal with how we handle a greater than sign next to an absolute value. Well, we split this into 2 pieces. The first piece, we'll just remove the absolute value sign. That'll be 2/3 x minus 5 greater than or equal to 3. But for the other side, we'll have 2/3 x minus 5. We're going to change the sign to a less than or equal to and change this sign to an opposite, which is be -3. There. Now we have our 2 parts. This is treated much differently than the less than sign. You see the greater than sign is broken into 2 pieces. So now let's begin to solve each part. Add 5 to both sides. We end up with 2/3 x is less than or equal to 2. And again, multiplying by the LCD of 3, we get 2x less than 6. Divide everything by 2. I end up with x is less than or equal to 3. Now, the graphic for this would be a line here. This is less than 3, so the left side will go to infinity, whereas the right side will stop at 3. Here I'll solve for this inequality, so plus 5 on both sides. We end up with 2/3 x minus 5, 2/3 x, that's no longer there, is greater than or equal to 8. Multiply by the LCD, which is 3, and we'll get x is greater than or equal to 24. Or 2x, should I say, 2x is greater than or equal to 24. Divide both sides by 2, we'll get x is greater than or equal to 12. The graphic for this is x is greater than 12. It's to the right, it goes to infinity. And here on the left, we'll solid line at 12. So this is the graph. Now, the interval notation for this is represented by -infinity to 3, bracket, union, bracket, 12 to positive infinity. So these are the 3 ways that we can actually write this answer. Interval notation, the graphic, and set notation. And again, interval notation, the graphic, and set notation. Now, for number 9, I would love for you to attempt the absolute value, and let's make this a greater than sign as well. And let's make the expression 2/5 x plus 4, and all of this will be 2. In fact, let's just remove the equal sign and just make it strictly greater than 2. Give that one a try.